All right, let's do the next example. Don't be afraid that there's two terms here. We can do this. We want to find the area of this and the x-axis from -2 to 2. So in order to do that, we are going to say the integral from -2 to 2 of 4 minus x squared dx. Now remember that our integral sign applies to both of these, and we can apply it to both of them independently. So the integral of 4 is 4x, and the integral of x squared is x cubed over 3. So double check that, take the derivative of both of these, and see if you get 4 minus x squared. We're then going to evaluate that from -2 over 2. Here's where people make most of their mistakes. There's going to be a lot of minus signs here, and we need to be careful to keep track of our minus signs. Remember, we're doing f of b minus all of f of a, so this minus sign will need to distribute to everything. First, we plug in the 2, so it's 4 times 2 minus 2 cubed over 3. That's f of b. That's f of plugging in the 2 value. You plug in 2 here and 2 here. We get 4 times 2 minus 2 cubed over 3. Then we're going to subtract, that's this minus sign, and now we need to subtract all of f of a. So I either recommend putting this all in parentheses, or I recommend flipping the sign as you go each time and then adding. All right, now we plug in -2, so that's 4 times -2 minus -2 cubed over 3. And that is evaluating this function from -2 to 2. So that's going to be 8 minus 8/3 minus -8 minus -8 over 3. So see how many stinking minus signs we have? These two minus signs become pluses. And when I distribute this minus sign, it'll be 8 minus 8/3 plus 8 minus 8/3. Okay. Now, notice that that's going to be 16 minus 16 over 3, and that's our answer. So you could convert that to decimal if you wanted to, but that will be the answer. Now notice these two amounts were the same. That's actually not an accident that these two amounts were the same, because if you look at our function, 4 minus x squared, that looks like this, and we evaluated from -2 to 2, which are the roots. And notice that that's symmetrical. So it actually shouldn't be too much of a surprise that we got the same thing here and here. That won't always happen, obviously, but it did happen this time. This area we just discovered is equal to 16 minus 16/3. Okay, let's do another example. Here we're doing y equals 4 over x, evaluated from 1 to 6. I'm going to start doing these kind of quickly. That's 1 to 6 of 4 over x dx. The antiderivative of, here's a good one. What is the antiderivative of 1 over x? In other words, the derivative of what? The derivative of what will give us 1 over x? Do you remember? Do you remember? Pause the video and see if you can remember. The answer is natural log of x. So the natural log of x, the derivative of that is 1 over x. So that means that the antiderivative of 4 over x is 4 ln x. Okay, so remember, derivative of natural log is 1 over x. So the derivative of 4 ln of x is 4 over x. Normally we'd have a plus c, but because we're actually evaluating a definite integral, we're going to just do that from 1 to 6 instead of doing plus c. So that's 4 ln of 6 minus 4 ln of 1 when you evaluate it. And by the way, the natural log of 1 is 0 because e to the 0 is equal to 1. So our answer is just 4 ln of 6. Let's do another one. We'll do these two and then call this video a day. Integral from 4 to 3 of 5x cubed plus 7 is going to equal 5x to the 4 divided by 4 plus 7x, evaluated from 3 to 4. So take the derivative of both of these, check your answer, make sure you get this right here. As we evaluate this, this is going to be 5 times 4 to the 4 divided by 4 plus 7 times 4 minus, and don't forget your parentheses. That's maybe the most common mistake. Now we plug 3 into the entire function. So 5 times 3 to the 4 divided by 4 plus 7 times 3. Okay, that's how you do this. Okay, let's just wrap it up. One of these 4's will cancel, making that a 3. So that's going to be 5 times 64, which is 320, plus 28, minus, one of these 4's cancel, so that's 3 times 3 is 3 to the third is 27, times 5. So I'm going to write minus 135 minus 21, because remember that negative sign distributes. 320 plus 28 minus 135 minus 21 is equal to 192. That's our answer. See how easy it is? We don't have to mess with rectangles or anything. We can just use the antiderivative and use the power of calculus. Let's evaluate this last one. The antiderivative of 3e to the 4t is 3e to the 4t divided by 4. Because when we take the derivative of this, the 4 would come out because of the chain rule, which would cancel with this 4. So take a look at that. Make sure you agree with that, hopefully. That would be evaluated from a to b. Now don't be afraid that it's a t instead of an x. The variable letter doesn't really matter. So this is just going to be 3e 4b over 4 minus 3e 4a over 4. And now you've got a function for any values of b and a that you want. And indeed, you can just plug those in for b and a and get whatever you want, whatever area you want. We could do a little bit of factoring here to simplify, but I'm honestly going to leave my answer just like that. I want to point out one more thing before we move on. So far, all of our answers have been positive, and that's not always going to be the case. So if we have a function that looks like this, say, and let's say we're taking this area right here, you notice that there's a lot more area underneath the x-axis than above. So when we do this, we're probably going to get a negative answer. That does not mean we have negative area. It just means that there's more area below the x-axis than there is area above the x-axis. Or maybe sometimes there's no area above the x-axis. So don't be afraid when you're doing this that you might get a negative answer for area. That just means you have more area below, which will cancel or just remove any of the positive area above. All right, hopefully you like these definite integrals. They're a lot easier than what we were doing in the previous section. We'll stop here and do some application problems in the next video. See you there.